4R, Nitrogen Management of Winter Wheat During a Drought.
Should all your nitrogen requirement for winter wheat be applied at seeding, or should you wait until spring to broadcast or dribble band your nitrogen? You may find you'll get a wide range of opinions on this because it depends on the environmental conditions and how you manage your nitrogen. If you side band all your nitrogen at seeding, there will be lots of time for the urea to convert to nitrate, particularly if the soils are warm and wet. Once in the nitrate form, nitrogen can be lost through leaching or denitrification. Denitrification is a process whereby soil microbes use up the nitrate as an oxygen source under anaerobic conditions.
During our wet summers around 2010, I knew a producer near Yorkton who put all his nitrogen down when seeding winter wheat. In the spring, the crop looked a little light green, and I suspected he may have lost his nitrogen. The field wasn't going to receive any additional nitrogen because it was too wet to drive on and he needed to get to other fields to seed them. But I broadcasted some nitrogen by hand, and it soon became apparent that the field probably lost nearly all of the nitrogen that had been applied in the fall. He could have used a product like Super U or ESN to reduce N losses. Super U contains a nitrification inhibitor which slows the conversion of ammonium to nitrate. This reduces losses because ammonium is not prone to leaching or denitrification like nitrate. The ESN is urea covered in a polymer that delays release, and this too can provide protection from N loss. Under drier environmental conditions, side banding nitrogen at seeding may be the best thing to do. Spring broadcast applications of urea are prone to volatilization or gassing off if adequate and timely rainfall is not received. Of course, we can reduce this risk by using products like Agritane or Super U, which contain urease inhibitors. Dribble banding UAN can also reduce N losses because the nitrate portion is not prone to volatilization, and applying the product in concentrated bands helps to reduce volatilization of the urea portion. Agritane can also be added to UAN to further reduce volatilization loss. However, adequate and sometimes timely rainfall is still required to leach that nitrogen into the soil zone, and winter wheat is going to need that nitrogen early in the season to maintain yield potential. Splitting the nitrogen between the fall and the spring may prove to be a good way to hedge your bets.
So to demonstrate all these practices, we established a winter wheat trial on August 30th, 2019 at the Yorkton Research Farm. The trial established well with 287 plants per meter squared emerging. The winter wheat overwintered well, but treatments receiving all their nitrogen as side-banded urea looked a little better in spring. It was a very dry spring with only 50 millimeters of rainfall falling in May and June. The norm is 131 millimeters. However, despite the low winter yields, there was a lot of significant differences between treatments.
Here are the results for the winter wheat yield, bushels per acre in blue, and percent grain protein in orange. With the exception of the no nitrogen check on the far left, every other treatment here has received 110 pounds of nitrogen per acre. So you can see we had a good yield and protein response to added nitrogen. Applying 110 pounds of nitrogen per acre has increased yield from 22 bushels per acre into the range of 35 to 44 bushels per acre, depending upon how the nitrogen was applied. It has also pushed grain protein from 10.9% into the range of 12.5 to 13.9%. Let us focus on treatments 2, 3, and 4, which are side-banded applications of urea, ESN, and Super U respectively. Compared to side-banded urea, side-banded Super U has resulted in 2.5 more bushels per acre and 0.5% more grain protein. The Super U likely reduced denitrification and leaching losses, particularly since the winter wheat was seeded early, August 30th, allowing lots of time for urea to be converted to nitrate. Side-banding all the nitrogen as ESN resulted in a 6.4 bushel per acre yield loss, but a 1.2% gain in grain protein compared to side-banded urea. Side-banding all the nitrogen as ESN likely resulted in a late release of nitrogen that increased grain protein but was too late to maintain yield potential. Having only a portion of the nitrogen as ESN may have proved to be more beneficial in terms of yield, but unfortunately this treatment was not part of the study. Let us focus now on treatments 5 to 8, which are spring surface applications of nitrogen. Treatments 5 and 6 are broadcasted urea and agrotane-treated urea, which were applied on April 24. Treatments 7 and 8 were dribble-banded applications of UAN and agrotane-treated UAN, which were applied on May 11th. Ideally, dribble-banded and broadcast applications should have occurred on the same date to allow for fair comparison. However, enough rainfall to incorporate the product was not received for 2 weeks for either application date. Neither yield nor grain protein significantly differed between these methods of spring applying nitrogen. However, crop yield and grain protein were numerically higher when agrotane was used with urea or UAN. This implies agrotane was providing some protection from volatilization loss. When we pan back out, it becomes evident that all spring applications of nitrogen, treatments 5 to 8, produce less yield than fall side-banded urea or side-banded Super U, with differences being statistically significant relative to side-banded Super U. However, all the grain proteins for the spring applications were statistically higher than the grain protein resulting from side-banded urea. The lower yields and higher protein from spring applications implies the availability of nitrogen was delayed relative to side-banded applications at seeding with the previous fall. This stresses the importance of applying spring nitrogen early for winter wheat and the importance of early season rainfall to move it into the root zone. When application of urea was split in half between fall side-banding and spring broadcasting, treatment 9, the result in terms of yield and grain protein was very similar to placing all the urea in the sideband at seeding. Again, this shows the importance of early season nitrogen for maintaining yield in this study.
So there was some evidence that Super U and agrotane were providing better nitrogen use efficiencies. But was it more economic? You tell us, Mike.
Well, actually it was. The last column in this table can be used to make fair economic comparisons between treatments. It is gross returns in dollars per acre minus the cost of the nitrogen minus the cost of any additional applications required. Gross dollars per acre is simply bushels per acre multiplied by dollars per bushel. The dollars per bushel were determined based on these protein spreads. The base cost for nitrogen for both urea and UAN was assumed to be 50 cents a pound. The added cost per pound of nitrogen for using ESN, Super U, and agrotane-treated urea or agrotane-treated UAN are listed below. For example, the added cost for ESN is 14 cents a pound of nitrogen, so the total cost for using ESN-treated urea would be 50 cents plus 14 cents, which equals 64 cents per pound. These end costs have been presented in this table on a per acre basis. For the treatments requiring a spring surface application of nitrogen, an additional cost of $5 an acre has been included. So from this table, it is evident that the no nitrogen control resulted in the lowest economic returns. That's good. Applying nitrogen wasn't a waste of money. Side-banded Super U provided the greatest economic returns because it provided the highest yields and a decent protein level. In contrast, ESN provided the worst economic return, next to the no nitrogen check, because higher price per bushel due to the higher protein wasn't enough to compensate for the relative yield loss. Again, ESN likely would have done better if it constituted only a portion of the side-banded urea. Side-banded urea alone provided similar results to spring applications of nitrogen. However, you'll recall the nitrogen for the side-banded urea was available earlier in the season and partitioned more towards yield and less towards protein than spring applications of nitrogen. While not large, the use of agrotane with broadcast urea or dribble-banded UAN did improve economic gains.
So under the dry conditions of our study, it was best to put all the nitrogen down at seeding. And even though it was dry, side-banding Super U instead of straight urea was beneficial. Using agrotane for spring applications can provide some benefit, but if adequate and timely rainfall is not received, the nitrogen is not going to get to the crop on time to maintain the yield potential. If conditions are wet, then you definitely need to consider using Super U at seeding. However, a split application with some N applied at seeding, followed by some N in spring, might be the best way to hedge your bets, since it's difficult to predict the weather.